Okay guys, today what we're looking at is radian measure. And before we start, let's talk about our goals for today. We'll be able to define radian measure. By the end of today, we'll be able to convert between radians and degrees. And by the end of today, we'll be able to use radian measure to calculate trigonometric problems. Okay, so let's start by talking about the definition of radian measure. And a radian definition is the angle subtended at the center of a circle by an arc length equal in length to the radius is 1 radian. So, and we'll talk more about this in a second, but if we look at the diagram here, okay, here's a circle with radius r, and over here we have an arc of length r as well. So a radian is sort of like a way to measure degrees, because 1 radian is the same as, this many degrees, which, we'll talk about in a second. Okay? So a radian is just another way to measure degrees in a circle, but it's a more convenient way to measure degrees, as you'll see when we start to do trigonometric functions. Okay, so moving on, let's talk a little bit more about radians. And specifically, a general way to define a radian is theta equals s over r, where theta is the angle in radians, s is the length of the arc, and r is the length of the radius. So if we look at a very general example, this is one where we're looking at a half circle. Okay, the circle has a radius of r, and the length of this arc is going to be s. Right? This is theta radians, right, or 180 degrees, as you can see. So in this case, s, the length of s, right, if we remember our geometry, 2 pi r is the circumference of a circle, and the length of s is half of that, so half of 2 pi r is going to be pi r, right? And if we look at our theta equals s over r formula, right, s is just pi r, so that means theta is pi r over r, r's cancel. What we are left up with is pi radians. So from here we have our first equivalence, which is pi radians is the same as 180 degrees, right? 180 degrees, half the circle, is pi radians. And from there we can sort of convert between radians and degrees for a number of very common angles. So if pi radians is 180 degrees, then that must mean 2 pi radians is our old friend 360 degrees, right? And halfway between that, halfway between pi and 2 pi is 3 pi over 2 radians. Well, that's going to be halfway between 180 degrees and 360 degrees. It's going to be 270 degrees, right? And we can work our way through and figure out all of our common angles, right? Pi over 2 is going to be half of this. That's going to be our 90 degrees. And even our common 30 degree angle, 45 degree angle, and 60 degree angle, right? So we've got pi over 6 radians is 30 degrees, right? That's this one divided by 3, right? This one divided by 3. Pi over 4 radians is equal to 45 degrees, and that's this one divided by 2, right? So pi over 2 divided by 2 is pi over 4. And finally, pi over 3 radians is our 60 degrees. And that's just going to be double of this, right? So this times 2, that's where we get it. So these are our common angles that we'll find and we'll be working with over the next couple of lessons. Okay, so now let's take a look at an example problem. And this is the first graphing problem you're going to be seeing with radians. And here we're going to be sketching the graph of the function f of x equals 4 sine x plus 2 for the domain 0 less than or equal to x less than or equal to 2 pi. This is, again, in radians. And the only thing that's really going to change is the x-axis, right? When we've been graphing problems with degrees, the x-axis goes from 0 to 180 to 360 degrees. Now, instead of going from 0 to 180 to 360, we're going to be going from 0 to pi to 2 pi, right? But in terms of the amplitude and the axis, those things don't change. So over here we can see that the amplitude of this graph is 4, right? And the axis is y equals 2. So we can continue to plot that normally, okay? So here's our 2, here's our axis. Amplitude of 4 means that we're going to go as high as 6, and we're going to go as low as -2 on our graph. And from there, it's just a normal sine graph, right? Going up, going down, and finishing back at the axis. Sorry, this should go a little bit higher. And this point right here, or actually I should start with this point right here, is going to be 2 pi, right? 360 degrees is normally how it would go, but since we're in radians, this would be 2 pi. This point right here, the midpoint, is between 0 and 2 pi. This is going to be pi. Usually it'd be 180 degrees. Now we're talking about pi. Right? This point, the maximum, pi over 2, and the minimum over here at -2 is just going to be 3 pi over 2. Okay, so it's exactly the same way of graphing, but now our x-axis has changed. Instead of 360, we're going up to 2 pi. Okay, for our next example, let's do some equation solving. We want to find all the values of x between 0 and 2 for which sine pi x equals 1/2, where pi x is in radians. So the first thing we want to think about is, think of this as a normal trigonometric function, right? So if I said sine of pi x equals 1/2, let's forget about the pi x for now. I know that sine is positive in which quadrants? Well, sine is positive in quadrant 1 and quadrant 2. So I know that I'm looking for something here and I'm looking for something here, right? Now in quadrant 1, what value is going to give me a sine value of 1/2? So what degree value? Well, normally it would be 30 degrees, but in terms of radians, 30 degrees is pi over 6 radians, right? So this is pi over 6 radians, and this is going to give me a sine value of 1/2. That means the alpha angle here is also going to be pi over 6, right? And I'm going to want to find my theta angle, right? Full angle coming over here. And this full angle is going to be what? Well, if this whole thing is 180 degrees or pi radians, then this angle is going to be pi minus pi over 6 minus the alpha, which equals 5 pi over 6, right? And if you double check, 5 pi over 6 radians is the same as 150 degrees, right? Which is exactly what's going to give us our sine value of 1/2. And so finally, my two answers are 5 pi over 6 and pi over 6, but remember we're solving for x here, and there's already a pi in there. So ultimately our answer should be, right, pi x equals 5 pi over 6. Let's take out that pi, right, cancel out these pi's. X is going to be 5 over 6. Same thing for the pi over 6, right? Pi x equals pi over 6. Let's cancel out these pi's. X is equal to 1 over 6. Okay guys, so for our practice problem today, I want you to find the values of x, where 0 is less than or equal to x, less than or equal to 2 pi, which satisfy each of the following equations. Obviously, they're going to be different values of x for a, b, and c. Again, this is just like solving these problems with degrees, only now your answer is just going to be in radians. So, for example, if the first one, your answer is going to be 60 degrees or 30 degrees, then instead of 30 degrees or 60 degrees, you would say pi over 6 radians or pi over 3 radians. Okay? And that's it. I'll see you guys tomorrow.